Good morning. In this video, we're going to review concepts related to place value and how we can use that to develop the procedural skill of rounding. As we've worked with the Pythagorean theorem, we often find that our side length when we take a square root is an irrational number, a decimal that never stops. So we're required to round numbers, sometimes to the nearest tenth, sometimes to the nearest hundredth, and sometimes to the nearest thousandth. It's important to understand that the tenths ask us to go to 1 decimal place, the hundredths ask us to go to 2 decimal places, and the thousandths ask us to go to 3 decimal places. The idea of rounding starts very simply. If we were rounding to a whole number, if I gave you something like 1.75 and asked you to round it to the nearest number, we wouldn't want to round to 1 because it's actually closer to 2 than it is to 1. So anything that's above 1.5 actually gets rounded up to 2.0. Anything that would be below 1.5 would stay when we round it to a nearest whole number at 1.0. That's important to realize that when we're asked to round to the nearest tenth, hundredth, or thousandth, we may actually have to bump up to the next tenth, hundredth, or thousandth. So let's practice the procedural skill now that we know that the tenths are 1 place, the hundredths are 2 places after the decimal, and the thousandths are 3 places. Let's take a look at some square roots that create irrational numbers. The first square root is the square root of 10. If we were to put that into a calculator, we would get the irrational number 3.16222, and it kept going. So I'm going to go ahead and write that's what we could write using this ellipses to show this is an irrational number that keeps going. But in the real world, we're going to have to round this number off. We need to stop it at some decimal point. Even Google's calculator up here, when we did the square root of 10, they had to round it off. They just did a place value much greater or much smaller than the nearest thousandth, closer to the nearest millionth or the nearest billionth. Pause the video and try to figure out what is this number, the square root of 10, rounded off to the nearest tenth, to the nearest hundredth, and the nearest thousandth. Welcome back. Hopefully you realize that square root of 10 to the nearest tenth is going to be 3.2. The reason for this, first we got to look 1 place after the decimal. We have 3.1, but that 3.1 is going to round it up because when we see the 6 come after the 1, we know this is actually closer to 3.2 than it is to 3.1. If we were asked for the nearest hundredth, that's to 2 decimal places, we'd say 3.16. When we look right after the 6, a 2 is smaller than 5, so we know that this number, the square root of 10, is closer to 3.16 than it is to 3.17. The same thing goes for the nearest thousandth, that's to 3 places. When we see a 2 following the 2 that's in the thousandths place, we know we're not going to round up, we're going to leave it at 3.162. Now, if you do the square root of 20, we get 4.47213. And if we do the square root of 40, we get 6.32455. Go ahead and figure out how do we round those numbers to the nearest tenth, hundredth, and thousandth by pausing the video. Welcome back. Hopefully you realize that the square root of 20 rounded to the nearest tenth would be 4.5. Again, we need to round up when we see the 2 come after that 7. When we see the 7 come after the 4, we need to round up. And then for 6.32, we would just leave it at 6.3 because in this case, it's the 2 that follows the 3. We're not going to have to round up. The nearest hundredth would be to 2 places. We'd say 4.47. We're not rounding up because this is a 2. And we'd also say 6.32. We're not rounding up because this is a 4. Finally, for the nearest thousandth, hopefully you saw 4.472. We wouldn't round up, but for 6.325, we would end up rounding that 4 up because the following digit, 5, tells us we need to round up.